I had a question about global warming last week. The question was what was the pre-industrial average temperature? And we're going to talk about that because it's interesting to see how we get the information, how we look at the statistics, and how we can play with the numbers sometimes, and hopefully that will make sense as we go along. So here is an example of information we could get on the warming of our environment. So this one here is from climate.gov. You can see we have here the difference from 1901 to 2000. So if you go from 1900 to 2000, we take all of the temperature, we do an average, and this becomes our reference point. So the reference point here gives us, and we want to know, are things getting warmer or colder from that perspective? Now I want you to look at something here, is that here we have the yearly surface temperature from 1880 to 2023. So here, this is the beginning of the Industrial Revolution. But here we have our average, the 20th century average from 1901 to 2000. You have to keep in mind that sometimes people play with those averages, and we'll have a quick look here. So as you can see here, we have an increase of temperature of 1.18 in 2023 using the average of 1901 to 2000. Perfect. Now you have to keep in mind that if you are, so when I went to school, we were looking at the beginning of the studies of the global warming. And here it's a bit different. You could see here the average. So the global temperature anomaly compared to 1951 to 1980. So we have in this middle part here. So they look at this 30-year, made the average, and that became the baseline. Now, if you go back in the early 80s, that's when scientists started to say, okay, well, I think we noticed there's an increase in overall temperature. And maybe you don't remember, but we had the Paris Accord in 2015. There you go. We had, there's always the Conference of Paris happening every year. So what happened here is that we had in 82, the first grouping of scientists. They met in Kyoto, and the Kyoto Accord was signed. At that time, they looked at the information from the previous 30 years. And the reason for that is that if you think of geography and climate, we always define climate from the data from the previous 30 years. So they look at previous 30 years, then they look at what the information is, and that gives us a good idea of what climate was. So what they did is that in the 80s, they looked at the average of the previous 30 years, and then they realized that compared to post the beginning of the industrial age, we had increase in temperature, and they were saying there's a chance that there's an increase happening. And guess what? Since 1982, there's been a get together in Brazil, in Copenhagen, in Kyoto, in all over the world to try to figure out what we can do. And as you can see, we have an increase in overall temperature. The reason why people are worrying about how climate are is that if this is all the way to 2022, for example, we have here 2023, the last 30 years gets us from 1983. So if you were to take the average, let's see if I can make it a bit bigger for you. If you were to take the average of the last 30 years, we have an average of probably 0.5 degrees warmer than the baseline from 1950 to 1980. And this is probably about 0.25 degrees warmer than between, let's say, 1880 to 1910. So what happened here is that we have an average of 30 years that is increasing all the time. So here we're looking at the hottest year on record for a long time. It's interesting to see how it goes. But look how the average reference point is. This one is from 1951 to 1980. This one here, we took data from 1900 all the way to 2000. What's the best way? The question here is that sometimes scientists will take one or the other depending on how they want to look at the average. averages. Perfect. So let's see if we can look at something else I wanted to do. So here's another example. So here we have another one from, it's a CSSR. We have a summary of the global land and ocean temperature anomaly. And if you look here, since 1880, you could see that we have, let's see if I can, I'm going to take my face out of there. There you go. You could see that there's a lot fewer temperature under the baseline and a lot more since the 1940s. And if you were to look here we're looking at the annual average temperature has increased more than 0.7 degrees for the period of 86 to 2016 relative to, so here they're using the year 1901 to 1960 as their baseline. So if you were to look at, let's see, 1900 to 1960, if you were to look at these here as the baseline, it would be a bit cooler as an average. That means that we would have a graph that would show a much bigger increase here. I'm not saying that one is better than others, but you always have to look at the data and what information scientists or social media influencer or the current news journalists are telling you. That's something to look into. Very nice. So going back to the question, what was the pre-industrial temperature? So let's see. So we are here in, so this one dates 2005. So let's see if you go back a little bit. So here we have our historical values in mid 20th century. If you go back a little bit, you could see that it's a bit cooler right here. And here you could see so that there's ups and downs in temperature, which more or less was constant in the last 10,000 years or so. But you can see that there's been ups and downs in temperature as we are going along. Now, keep in mind that if you think of last 10,000 years, that's when most of humans so the human population increased. We went from nomads to more sedentary cultures, and therefore we humans went where the environments were great to grow food, to raise families, and have great economies. However, what we notice is that in the last, let's say, 100 years, there's quite a few differences that happens. I had another graph, and I don't know where it is. Where is it? Let's see. Is it this one? Okay. So what we notice is that as we are looking for data, so here we have another example where the average from 1901 to 1960. So what happens is that we notice that there's an increase in overall temperature. So the overall global temperature of the planet. And the reason why we say it's related to the global carbon emission is that if you do the graph of the annual carbon emission, since the Industrial Revolution, we've been using more and more fossil fuels, and therefore carbon dioxide has increased in the atmosphere. Now you have to be careful because sometimes people are using carbon dioxide as being the biggest issue for us, but often scientists are talking about the carbon equivalent, because here we talk about carbon dioxide because people know what it is. However, methane is a greenhouse gas. We also have CFC. We have several other gases that can actually create greenhouse effects. But what's interesting is that if you take, for example, this idea of increased carbon in our atmosphere, it goes with the increased carbon, the increased temperature of the planet. And if you look at the graph with the increased population on the planet, they more or less overlap. So that's why people are saying, as humans, we need to figure out what we can do about this. And as you can see, different models mention that if we don't stop what we're doing, temperature will go up. If we are changing, it might stabilize in 100 years, or maybe early if we can do more. But as you can see, these are models based on the information we have. Good. You have to keep in mind that if you look at this graph right here for the last 800,000 years, this is data from ice core from the Antarctica. We are right here in the age zero, where we're close to this this average temperature that we've had lately. But as you could see, we've had, like, if you go back, let's say 50,000 years or 100,000 years, we had the last ice age. Before that, we had a time of warm. Then we had an ice age, warm time, ice age, warm time. So here's like we're a fifth cycle in the last 800,000 years that have temperature going above our reference line. So it has happened in the past, and at that time, we didn't have all the humans we have. I'm not saying that it's not related to human activity. I'm just giving you ideas for you to look into. Perfect. This one, so this one right here, and is it this one I want to show? There you go. So the question is, what will happen in the future? That's a great question. If you go back, overall temperature, they were more or less the same for the last 10,000 years. And yes, before that, it was down. But keep in mind that a change in atmospheric chemical composition, it's like when you have, let's see, how does it called? It's called a cruise ship. There you go. If you have a cruise ship, which is a large ship, and you want to turn the ship, you cannot turn the ship within 100 meters. It's impossible. You have to slowly make small changes, and over long distance, then you can turn your cruise ship much more easily. It's the same thing with the atmosphere. The atmosphere composition has changed over the last 100 years. And if you check, if you were with us in the last 4 billion years, the atmosphere of the Earth has changed quite a bit all the time. So humans are a bit worried because in the last 10,000 years, we've been settled where we are at, and we're happy. And changes and migration that may need to happen due to the change is something we'll have to look into. So here we have the historical temperature that I set. The methodology and the underlying assumptions are flawed. Also, they never include solar forcing. That's very true. So the sun has the output. So you have to, if you think of the heat of the planet, there's the sun output that is to consider. There's also the energy reaching us as a planet, but there's also how much energy gets in our atmosphere. Depending if there's more clouds or not, some of the energy is reflected back into space. We have also, we have the decomposition of the atmosphere will contain more or less heat. The way the oceans are will contain more or less heat. If you have ice cover, it creates reflections, and therefore the albedo of the planet is changing as well. There's so many factors that need to be looked into. However, it makes a lot of news. I remember, if you think of the last 50 years, when I was in high school, it was in the 80s, they were saying that there'll be no let's say fossil fuel by the time we would get to the year 2000 and society would collapse. That's what I was in school, they were saying. In the 70s, they were saying that we were going back into an ice age. Then we had the difficulties with the ozone, which was about to destroy what the Earth as we knew it. There was every decades or so, there's a new story. And the big question here is, how can we get the best data? How can we, let's see, better understand the environment? But the other one here is we have to take responsibility as well. So it's probably not one of those extremes. It's probably a mix of all of those that makes an overall situation and understanding of what it is. That's my understanding on this one. If you have clarification questions, please put them in the comments below. If you disagree completely with me, put your comments and I'll be able to answer. If you think it's good to think about different options, I think that's something we have to look into. because climate change, the biggest thing is that humans may have to move from where they are to other places where the environment is better to grow food or to have cities. And that's why you're starting to see that where we have environmental refugees moving because of water access, food access, places where they can grow their own food and grow family. And we have to keep in mind that the growing world population is putting pressure on that as well. So hopefully that answered the question about how was the temperature pre-industrial revolution. It was a good question. I had to do some research on that one, and thank you very much for that question. On this, I'm going to put here, let's see. I'm going to put here another link to a video related to the environment. I'll see you there in a moment.